All right, the male and female knife shafts are removed from the knife trunnion slitting area by first removing the bearing caps. I loosened all the knives. I moved them to the center to make it a little safer lifting them out. Now this knife shaft is captured on this side, which means there's two bearing keepers that keep the shaft in position in the machine from shifting from left to right. So now we're going to lift it up and out. This side has to come out first, and this side will also go in first because this is the captured side that holds the bearings in the retainer. All right, that's the male shaft. Now the female shaft, similar, bearing caps hold it in the bearing housings, and is also captured on this side of the machine, which is the drive side, which keeps the knife shaft from moving left or right in the machine. This one has a drive tang on it. The drive tang is engaged in the transmission, which drives the female knife shaft. I think you can see it from the video as it's rotating the knife shaft. There's a drive tang located over here. It has to be facing in the up position. Similar to the rewind mandrels, it's only going to come out in the one direction. So that drive tang needs to be facing up just like that. And then the bearing housing is machined so that it captures the bearing to keep it from moving left to right. And now we're going to take this knife shaft up and out, similar to the male shaft, except this is the female shaft. Take either side, up and down. Drop it. There you go. All right, these are the two knife shafts that are out of the machine. These are male knives, that's the male knife shaft. These are female knives with spacers, and this is the female knife shaft. As you noticed in the other machine, when the knife shafts were in the machine earlier, I explained about the drive gears. And the female knife shaft is driven through the transmission and engages with the male knife shaft gear, and that's what drives the male knife shaft. Now, these gears, this one's positioned in a permanent fixed spot on the shaft, but the female gear has a set screw in it that can lock it in place on the flat of the shaft. However, the spacers and collars, as a sandwich, get tightened together. Knife spacer, knife spacer, knife spacer, that dictates your slit width. So whatever the tolerance of your slit widths stacked together, that's what makes knife spacer dictates your slit width. So you have to have different size spacers in between your knives to get whatever slit width you want. This is just a test setup that we put in, but you will have your own knives and your own spacers that you'll stack together on the shaft that will give you your slit width per your application. Now these collars on the outside here, this is a handle that goes in the collar. And these collars, the collar on the male knife shaft is basically just positioned somewhere convenient so that you can hold onto the knife shaft while you're tightening the knives, and you're in the machine safely because you're not holding onto the knives with your hand. You have the collar on with the handle on it. these collars on the female knife shaft now will lock the whole stack together as a sandwich, so that this way here they're all stacked up tightly, holds the female knives in position, and that's what will keep your knives together on the knife shaft when you lock this collar on, because this end of the shaft is threaded and this is a threaded lock collar. So I'll crack the screw loose, and then as easy as taking a plastic hammer, loosen up the collar. Again, it's the threaded end of the shaft. Lock collar comes off. Now these spacers are basically just sitting on the shaft with enough thread exposed so that we can lock up this whole stack of knives and spacers, so that we hold it together, because the knives do not have any way of driving. It's just a round plain knife. There's no key or no drive tang in the knife. So when they're all sandwiched together and locked up tight, the thickness between knife spacer is what gives you your slit width. So these have to be put on the shaft in such a way that when we're able to slide them over, stack them up tight, we'll be able to lock this up and maintain your slit width. It's usually easier if you slide another spacer up, especially when you're putting the knives on. Instead of put one knife on at a time, you'll line up a spacer to it, and it will allow it to go on more square and slide easier. If you try to just position a knife or one spacer at a time, sometimes they get a little cocked, so you sandwich them up, and then you're able to slide it back two at a time. You don't want these too sloppy, because they're liable to get a little crooked. It's a precision fit. You don't ever want to take any sharp implement, a hammer or a tool or a knife, and nick up the body of either one of the knife shafts, because it'll be difficult to move the knives around and position them for your slits and getting the knives on and off if you want to take them off and resharpen them. So basically that's how you would take a female knife off and put it back on. So I'm going to leave it loose because I'm going to show you the type of slitting and how these rotary shear knives actually do the slitting. Take the spacers back off. We're going to take one knife off. Now the male knives are a little different. These male knives are a keyless male knife. These are our holders from in-house. I'm not sure if you have the key type, and that's what these slots are in the knife shaft. So if you have a key type, it's an eccentric lock that will rotate around, and normally there's a zero mark or a dot or some type of an arrow, so that when the knives are opened up to that largest point, you're able to slide them back and forth. But these are an eccentric lock. Whether you rotate them forward or backwards, it's going to lock up and not move from left to right. Right now in that zero spot, they'll be able to move left to right. If I lock them backwards or lock them forward, they won't move. Now there is a correct way to lock the knives. When they're in the machine and the knife shaft is rotating, the female knife shaft right now in the machine will be rotating in this direction. So the male knife overlapped on it is going to rotate in that direction. So therefore, we always want to tighten the knives opposite knife shaft rotation, so they'll have a tendency to stay tight and not get loose. And this way, everybody that runs the machine knows that the knives are always tightened opposite rotation, so you don't even have to think when you want to move them. You basically loosen them up, rotate them the opposite way of rotation, or with rotation to get them off, and then you can slide them off the shaft. Now, rotary shear slitting, the male blade, it's a blade on a holder with a spring in it. That spring side play is what generates your slitting action. This surface right here on the knife, that's your female cutting surface. This is the male cutting edge. The male knife overlaps the female about half the distance of that cutting surface. So that approximate position right there is where you want to set the mechanical stops for the depth of the male blades overlapping the female. If you're too shallow when you side load them, you'll wind up chipping them or popping them. So now the male is going to jump on top of the females and it's going to destroy the blade. So you don't want to do that. If you have them too deep, excessive, sometimes you get a curled edge on your material because the male blade is penetrating down way too deep in that gap, and it's causing the material from the opposite, the slit side, to kind of fold under that gap. So you really don't want that as well. So about half the thickness of the cutting surface is usually the ideal position, male to female. It's a little difficult to see when it's in the machine, so it's easier right now if I hold them out this way. To change these blades is basically a snap ring, comes off of here, the blade pops off the snap ring, the blade goes back on, and then this garter spring basically just pops off, and that blade is almost free floating at that point. So you need the spring back on there on that tapered side to hold the blade in place up against the snap ring, but that's what's going to generate, when you side load, that's what's going to generate your slitting action. Now sometimes I think you might use some blades that doesn't have a spring, it's got a flat rubber washer in there. That's just a different type of spring loading, or it's more of a rigid rubber washer, but it still gives you some type of cushion. So when these male blades are in the machine, they're going to be penetrating down next to this female, and when you side load it, maybe if we come over this side and take a look here. When we side load, we engage the male over the female, and when we side load it, see that spring action right there? That's the only thing that's really generating the slitting motion when this rotates. So if you're excessive and you overload these too deep, that's where the dial indicator comes into play. When we side load them, we want to touch the blade against male against female, but then we only want to side load it about half of the spring loaded cushion. We don't want to overload them, or it's going to put excessive wear on the males and the females, or it could chip or break the male. So that's the whole purpose of this spring and rotary shear. We overlap male to female about half the cutting surface, which I showed you here, about half the cutting surface. And when it's overlapped and we bring the males just up to touch the females, that's the point that we'll lock these down on the shaft. Then when you're going to slit, we have to side load it a few turns, which came out to be about 60 to 80 thousandths on our side load to get this to start cutting. If you have the males set, one touching, one away, another one kind of touching, another one further away, when you side load, they're all connected to one shaft and they're all locked down to that same one shaft. So if one touches first and another one touches a few turns later and another one is already touching, you're going to overload the one to touch first, and you're not going to be loaded at all on the one to touch second, and so on and so forth. So this one's going to start slitting, and then the other ones that aren't touching are not going to slit. So you're going to keep side loading it until you overload the one that touched already, and just to get these to cut. So what I would recommend at that point, if your knives are not set exactly in the proper position, you need to stop, you need to back up, and you need to crack the males loose against the females and reposition them. Now when we put this shaft back in the machine, because the female knives and spacers dictate the slit width. So that's your slit width, from this slitting surface to that slitting surface on the female, and so on and so forth. We put the knife shaft in the machine on the males, we slide these males around, get them so that we can drop it down in between that gap. Then we slide the males over to the females and lock them down one at a time. And then disengage it, raise them up, and run the material through it. So we're going to put the knife shafts back in the machine in a moment, and I'll show you how to set the knives when they're in the machine. All the male blades, when the blades are brand new, they're going to be approximately 105 millimeters on the diameter. All of these blades, because the blades are all on one common shaft, they all need to be resharpened as a set, because when they resharpen them, the diameter will get smaller. So if you have blades on the same shaft, that some blades are new, which is a larger diameter, some blades are resharpened, which is a smaller diameter, that's a problem, because now your blade penetration or your male to female overlap on your depth Some are going to be shallow and some are going to be deep, and you're going to wind up getting in trouble with the shallow ones versus the deep ones. So you always make sure that your male blades get sharpened as a set. Now when we talk about the female blades on the opposite shaft, which is the lower shaft, same scenario, that all of those female knives get resharpened as a set because they grind the slitting edge back on the female knives. They will take the worst case scenario, they'll grind one blade and measure all the rest of them so that they'll clean up on the grinder, and they'll grind them all back the same distance. So now when you use your same knife spacers and the resharpened knives as a set and you stack them back in the machine, they will all still give you the same slit width, knife spacer, knife spacer, knife spacer, from knife to knife, than you had before, even though they're resharpened, because they're all going to be resharpened back the same distance as a set. So it's very important that you keep a set of knives per shaft, per machine, and when they get dull or they get broken or chipped or what have you, you always need to keep them together as a set. If there's 25 knives for your worst case scenario, slit width configuration, you got to have 25 knives male and 25 knives female, always as a set being resharpened. So there's no question as far as mixing and matching different diameters or different grinds on your width of the females. All right, now we're going to put the two knife shafts back in the machine. The lower shaft, we got the drive tank facing up, which is the female shaft. We'll pick it up, put it in the machine. Get the drive tang lined up. Gotta come in, pick it up. There you go. Make sure that we're down in the captured bearing slot. Tighten up the bearing caps on the female knife shaft first. Now the spacing of the gear, you'll have to coordinate that with your spacers to make sure that the gear on the female knife shaft lines up with the gear on the male knife shaft. But it's basically just, you could shuffle around a couple of spacers to get it in the right position, so when you engage the male, you're in the correct position. Now be careful with these knives. We don't want to chip them or ding them against anything. Back in there, bearing cap on. Now these two mechanical stops here, it's a 3/4 inch wrench. I'm not going to move it now because these are basically your male blades on these holders. They're my holders for testing, but these are your blades. So this is the diameter blade that you sent. So assuming that that's the same blades that you're going to be using, these mechanical stops are already set. It's a little difficult to see in here with the camera, but basically these mechanical stops rest against a block when the knife turning is all the way down. So unless you regrind the diameter of these knives for resharp, then these will have to be readjusted to set the depth to the new blade. But if you right now, if you start with brand new blades like these were when you sent them to me, put them on my holders, it should be the same scenario when you get the machine at your facility. And these female knives are not going to change diameter because that is dictated by the geometry of the machine and the speed of the transmission. So that blade diameter is not going to change, or the machine won't run correctly. So the depth mechanical set point right now should be set perfect for you. If you need to adjust it after you put resharps on here on the males, then it's basically just crack the jam nut loose, you back away, you unscrew these stop bolts slightly, and it will allow the penetration to go slightly deeper to make up for the smaller OD of the knife. So now at this point, what we're going to do is I'm going to slide these knives over so they're within close proximity of the females, because I don't really know where they are yet until we get them close and lower the knife shaft down to the slitting position. So I'll get them close. So we don't want to chip the males against the females. So what I'll do is now we can turn the up and down hand wheel, and we can lower this down slightly. Now I like to start with the knife bank or knife trunnion. This yellow beam is called the knife trunnion. I like to start with that basically kind of centered in the machine. So if we just measure from this arm to the frame and that arm to the frame, it's pretty close to being centered. It doesn't have to be exactly perfect, but there is stop collars on here. So if you have it stroked side load all the way engaged or all the way disengaged, this collar is going to be hitting the inside of the stop or opposite inside the transmission. If it's all the way engaged, it's going to be against this collar. If it's all the way disengaged, it's going to be against the collar inside the transmission. So if we center up the trunnion right now, we have about 1/4 of an inch worth of left and right movement, or side load engage and disengage. So if I position these male blades now, I'm just going to slide them over and just eyeball down in between the gap and get it so I can lower the knife shaft, engage the males to the females. I could bring a light over here if it makes it a little bit better. Engage the males to the females so that we can lower the knife bar down, or lower the trunnion down, to get these males in between the female and the spacer. So now it looks like I'm pretty close. So now we got to make sure we can line up the gear and engage the gear. Okay, there's the gear. I'm into the gear. So the gears are mesh, male to female, and these blades are not bound up, they're not stuck, they're not touching. They're basically, if I put my hands on them here, I can float them back and forth to get them to adjust up. So now what you have to do is make sure that nothing's stuck or nothing's hitting male to female, which they are not, okay? So now I'll get that handle that we use to undo the lock collar when we had the knife shafts out of the machine. Make it a light. I'll rotate the transmission around so I can put this handle in here. This handle is only for setting up the knives. You have to remove it before you start the machine, okay? And that's basically just going to help us hold that knife shaft while we're snugging up the knives. Now, as you recall earlier, I mentioned that the male blades always get locked opposite the rotation of the shaft. So the machine is going to rotate in this direction, okay? So I'll back it up a little more so you can see. So the machine is rotating in that direction. The pull roll goes over, okay? That pull roll is going over, the knife shaft's going over. So the male knives will be driven in that direction. So we're going to lock the males up in that direction, forward, opposite knife shaft rotation. They're rotating that way, we're going to lock them this way. And that's just to make them have a tendency to stay tight and not get loose as the machine rotates. So now what we want to do is, with the trunnion basically centered, we want to take these male blades and gently slide them over so that the male is now touching the female. We don't want to put a lot of excessive force on it. We just want that male blade touching the female. And I'm just gently moving them over so the male's touching the female, okay? Now that's all basically done. So now I want to take this hook type spanner, and as I'm rotating it, just maintain a little bit of pressure so that the male blade is touching the female, and snug it up. You don't have to go super tight, because you'll wind up getting them locked on there and it'll be harder to move and you got to take them off. And because we're going opposite rotation, they're going to want to stay tight. They're going to have less tendency to come loose. So again, as I'm rotating them, I'm just trying to make sure I keep the male against the female. And this is where if you push them too hard and you load the males up against the female too much, this is where you'll get the scenario that the males, some are overloaded and some are not loaded enough as far as touching the 0 marker, which is the male just touching the female. Because remember, the knives right now are not going to be set for cutting. They're only just basically set up male touching the female. When they're set up for cutting, we have to introduce side load or engage the trunnion so that that spring on each knife has some engagement, so it causes the slitting action to occur. If the male blade doesn't touch the female blade with some type of tension, it's probably not going to cut good. It might give you a rough, jagged cut, but if you want a nice, crisp, clean cut, then you have to make sure that they're all set in the proper position and that they're all maintaining about the same amount of spring pressure or side load. And this is something that just takes a little time and a little practice, but it's not that difficult, but you just have to make sure that you're engaged in just the right position so that you're not excessively loaded, male to the female, or a gap. Alright, now, easy way, I'll take the handle out so I don't forget. An easy way is basically just looking from the front of the machine. You look down in here from the front of the machine. You might not be able to see it, but I usually just look down all the knives, and if you see the male just touching the female, then you know you're in pretty good shape. So now what I'll do is I'll back away the side load a few thousandths, disengage. I'll back it away, I'll disengage a couple of turns, okay? Disengage, there's a half a turn, there's another half a turn. Now it looks like there's enough room to raise the knives. I don't know if you can see that gap in there, but we just want a little gap to raise the knives. So now I can go up with the knives and nothing will chip. And I can go back down with the knives because I didn't move my side load again. And now we're back into where we're going to slit. So now again, the side load, if I go back, engage those couple of turns. Okay, now we're just touching at 0. So now if I go a few more turns to get about another 50 or 60 thousandths on the side load on the indicator, I go little quarter turns till about that. Now we have spring action, male to female, and that's what's going to make our slitting action take place. So now in order to raise them up again, I got to back away, make a little bit of a gap. Now I can raise the knives up. You always have to disengage, and we'll come over here and look at the hand wheels. Up and down basically would be bring the males down into that gap in between the females. Raise them to disengage the penetration of the male to the female. Now the side load, engage and disengage. Engage, when we turn this hand wheel this way, is going to send that knife trunnion towards the transmission. We always load towards the transmission, and that's where the edge of the bevel is facing as well. And then when we disengage, we back out the hand wheel this way, and we'll bring the bar away from the transmission. But you always have to disengage before you raise the knives. when we lower the knives and then we engage for slitting, and we look at the indicator and we get them engaged for slitting, now we can take the hand wheel and we can lock the trunnion down. So we're basically just using the backlash in the gearbox, backing it off until you're floating in the backlash. We don't want to raise it yet because we didn't disengage it. Now we want to disengage it so that the males are not overlapped on the females. Now we can raise it. So we always need to have that overlap where the male is not going to hit the female, because if you chip the male blades, they're not going to cut properly. So now we can go back in again. Now they're overlapped, we have the penetration properly, and now we're going to engage again without locking up the trunnion. Engage until, if we were running material, you'd see the slits come up. Then we lock down the hand wheel to hold it in place. So this is locking it down against the mechanical stop. So you always have to make sure that you just crack the down loose and then disengage before you raise the blades. Once the blades are disengaged, then we can raise the trunnion up. The knives just take a little practice, but the whole object is that they have to overlap. They can't be too deep and they can't be too shallow, and you don't want to overload them, but you need X amount of turns on the side load to be able to get your slits up. And if the slits look kind of rough and they're all rough, you just need a little more side load. If you have one that's cutting and a couple others that are not cutting, you could try a little more side load, but you're going to get to the point where you're overloading the side load of that one blade that's cutting. So more than likely, it's not positioned correctly. It's a little bit too far to one side versus the other blades. You have to physically stop and crack everything loose and reposition all the blades to match that one that's set in a different spot.